Okay, so today's lesson, we are going to look at the coefficient of determination. So coefficient means a letter, generally. So when we look at this coefficient of determination, it's r squared for us. So the lesson before, we looked at r, which was the correlation coefficient. Now this one's the coefficient of determination. So the determination one is r squared. So r squared tells us something a little bit different. It tells us the degree which we can predict one thing from the other. So for example, we've been doing, say, height and weight. So say we had the height here and we had the weight here. And then we had a scatter plot. And you might have said that, I'm going to make this one up, the R value was 0.8. So you said that was a strong, positive, linear relationship. Okay? So now, when we look at the R squared, so R squared is going to tell us how much, when you change the height around, how much influence or effect does it have in changing the weight, okay? So if it had like 100% change, that means when you change one thing, it's affecting the other one 100%. But if we have our height, there's going to be other factors, isn't there? There's going to be like, yeah, if you get taller, you're going to weigh more. But then there's other factors, isn't there? There might be diet or genetics and things. So it's not going to be 100% causes weight. If you're taller, will your weight go up? So what we have to do is we have to find this R squared value, and it was in our calculators, and we'll go over that in a minute. And once we've got that calculator, that value, they are really going to ask you to interpret. So I want you to really take note of that word. When you see interpret, that means you're going to have to write out this little blurb that I've put there. Yeah. So if you've had a look at the one above here, which says, we had an example. It said the correlation between height and weight is 0.8. So we knew that was a strong positive relationship. If you square it, so if you're given it, you can simply just square it. So 0.8 times 0.8, and you get 0.64. So the coefficient of determination for this one, so r squared equals 0.64. That's what you want. If they ask you to interpret, so if you're asked to interpret, this is what you've got to write. So you've got to write the following, and you're going to have to fill in the blanks that are there. So this is also going to be a blank, and that's going to be a blank. So let me write the one for our example. So I would write out the coefficient of determination tells us that now we're going to times our r squared. We know that's 0.64. We're going to times it by 100, so we get a percentage. So to be 64%. So it tells us that 64% of the variation in, now what's the response variable for this one? Remember, response is on the y. So what's the response variable? Weight. So the variation in weight can be explained by the variation in, and what was my explanatory variable? Height. So you always write the same thing, except for obviously you have to change what the actual r squared value is, and you'll have to write what the response is for your case and what the explanatory is. Okay? If we have one that we find out that the r squared is less than 30%, it's sort of called insignificant, because there must be some other factor that's causing the things to change. So we probably would not go on with studying or researching that. So say we might have found that there was a we looked to see if there was a correlation between smartness and blue eyes or something, and you end up, it's got nothing to do with it, so you probably get a 30%, so we'll say, yeah, let's go on. Alright, so, okay. Let's have a... Okay, so, calculating the correlation coefficient from the coefficient of determination. So, what they've given you, so they've given us R squared, and they want us to go back to R. Okay? If you square something, what's the opposite to squaring something? Just yeah, good. So we're going to use the square root. So, if we look here, they told me R squared was, see the coefficient of determination, R squared was this. So, if R squared equals 0.5210, then R must be, the square root. Now, square root could be plus or minus. Because if you think about it, if I say 2 times 2, do you get 4? Yeah? What about if I say negative 2 times negative 2? What does that answer give? 4. So when you say the square root of 4, say you started with that, you really don't know what it originally was, whether it was plus or minus, do you? You don't really know. That's why they'll say plus or minus. But remember, the R value tells us whether it's, it could be positive or negative. What type of R value would this scatter plot have?
Negative.
It'd have a negative. So when you write your answer, you are going to choose the negative option of square root 0.5210, okay? Because we do know, because they gave me that graph. So I know which one it is. Okay, so on the calculator, we find the square root is actually 721, I'm just going to go 8. We know, why do I know it's negative? Because they've shown me on this graph. I know the graph is a negative graph, so I know. So you might need to write a little note for that. So because I can see the graph is negative, a negative direction, I know the R value is negative, okay? So the data on the number of booze buses in use and the number of drivers registering a blood alcohol reading over 0.05 was recorded, and the correlation coefficient R was equal to 0.77 was found. It says, first it's saying calculate the coefficient of determination. So first you're asked to find R squared. And then, can you see that word there? Interpret. Interpret. That's when you know you have to write that saying. So first of all, we're going to square 0.77 and find out what R squared is. So let's do that. So I get R squared to be 0.59. Now, they've asked me to interpret. So I'm going to say the coefficient of determination tells us that, now I'm going to times that number by 100. So it tells us that 59% of the variation. Now I need to know what the response variable is. Now here up here, when they're saying the data on the number of booze buses and the number of drivers registering, so we're just going to say that the more booze buses you have, probably the higher you're going to pick up more, maybe. So we might be saying this is our response variable and this one's our explanatory. This one's a little bit harder, so don't stress. I reckon you would always be given what it is. Okay, so the coefficient of determination tells us that 59% of the variation in drivers registering blood alcohol reading, I'm going to say blood alcohol limit, is explained by the variation. So I'm just using that template on the page before. The variation in number of booze buses. If we look at this last question that they're asking, is there a causal relationship? State the most likely variable to be the cause and the variable. We've sort of done that. There would be a causal relationship. The more booze buses you have, don't you think the more people you're going to catch because they're going to pull over more people? But really, is that if I put more, does that mean if I put more booze buses out, does that mean we've got more drink drivers? No, we're just simply catching more, or more are getting caught, or there probably could be the same amount and things. So that's what you sort of got to argue. Even though data can say some things, it doesn't really necessarily prove something, does it? Yeah.